All right, as we get started today, I want to review very quickly a couple things we talked about after yesterday's quiz. I talked to you about the relationship between two lines, and I said typically, if you were to draw any two linear equations at random, one equation may be something like that, one equation may be something like that. Normally, if you just draw two lines at random, the two lines will at some point intersect. But I said it is possible, and we've seen this before even yesterday, that the two lines may not intersect. That is to say, Brecken, the two lines may be parallel to each other. And class, what was the requirement for two lines to, rather than intersecting, to run parallel to each other? Class? That was really weak. I heard Brecken. Let's try that again. Class, all of you now, what's the requirement for two lines to be parallel?
Same slope.
Same slope. Now I said, in addition to intersecting, there's a very special way two lines can intersect. They could intersect in such a way that they formed right angles to each other. Maddie, we would describe these lines then as being perpendicular. And I said, really, for perpendicular lines, their slopes have to be exact opposites of each other. Like these lines, these first two I drew, they intersect, right? But they're both still positive slopes, right? Well, you can't have two positive slopes be perpendicular. Rather, one must be positive, the other must be negative. Not only that, but the rise and run must be at opposite rates. So we said for lines to be perpendicular, class, the slopes have to be two words, negative reciprocals. Negative reciprocals. Your homework last night was to answer yes or no about some lines. Are they parallel? Are they perpendicular? You also had some word problems. Now, we're not going to look at the word problems yet. We're going to go over those tomorrow. So hold on to that handout. The handout, again, was in the description of yesterday's YouTube video, so find that, Gavin, if you have not already. But just yes or no to four different questions here on page 119, four questions on the next page. Looking at 119, number one, as we look at those lines, are they parallel, yes or no? Noah?
Yes.
How do you know?
Because it says 2x more.
Right, so for each of them, the slope is? Yeah, it's the same. And what is the slope for each of them?
2x.
Maddie? 2. Whatever comes before the x is the slope. Y equals mx plus b. M is whatever comes before the x. So on number 2, no. Are they parallel or not? No, because on the first equation the slope is negative 3. And on the next one the slope is positive 3. That's not the same thing. They're not parallel. What about number 3, Maddie? Because they have the same slope, both of them negative 2/3. And then number 4, Brecken. Yes, because both of them have a slope of 5. Turn the page. Number 21, asked if these are perpendicular or not. Okay, number 21, perpendicular, yay or nay, Matty? Yay, because the slopes are negative reciprocals. Good. Inverse signs, one's positive, one's negative, and the reciprocals as well, negative reciprocal slopes. Number 22, yay or nay, Noah?
Nay.
Nay, they are not, forsooth, perpendicular. Rather, they are heretofore parallel, aren't they? Because they have the same slope. But that wasn't what they were asking about, was parallel. They were asking about perpendicular, and they ain't that. Look at number 23, yay or nay, perpendicular, Brecken. Yay, forsooth, one half the slope of negative 5, the other positive 1/5. Those are, two words? Negative reciprocals, therefore they aren't perpendicular. And number 24, class, yay or nay? Yay, they are, again, negative reciprocal slopes, perpendicular lines. Again, not just negatives. For instance, you flip back a page again. Look at number 2 again. Those are negatives of each other, right? But that's not perpendicular. They just happen to intersect. And you might see reciprocals. Well, that's not anything special either necessarily, but negative reciprocals would make perpendicular. You're right there on page 120 again, so flip back. Real quick, what would be the negative reciprocal of a half? Maddie? Well, that would be the reciprocal. What about the negative reciprocal? Negative 2. Look at number 18. What would be the negative reciprocal we would be looking for there? Noah? Positive 4/3. How about number 19, Brecken?
Negative 1/4.
Negative 1/4. And then Maddie, number 20? Good, negative 3 over 5. Good, so again, looking for negative reciprocals when it comes to perpendiculars. Again, make sure you hold on to that homework handout. Back to page 119 now. Now, all of those that you looked at yesterday were already in slope-intercept form. So all you had to do is literally look at it. You could see the slope staring you in the face. As we look at number 5 on page 119, it's not the case. Number 5, we've got an equation 3x. Positive 2y is equal to 6. We've got another equation. Noah, you're making noises there. 3x negative 2y is equal to 4. I can't look at this and see the slope. So what I would want to do with each of these to determine if these are parallel or perpendicular or perhaps neither, just random intersecting lines, I would need to get them into slope-intercept form. Noah, what would this equation look like in slope-intercept form?
2y equals negative 3x plus 6.
All right, and don't finish it out, but what's the slope going to be? Divide by 2? What's the slope? Negative 3x. Now, I would also technically divide this by 2 to get my y-intercept, but if all I'm concerned about is what's the slope, I got as far as the slope, negative 3/2, right? Coming over here, Brecken, let's find the slope. A couple ways you can approach this now.
Double slot.
Okay, to get
2y equals 3x.
there we go. And he had the 2y over here, but just so we could see the double swap on the chalkboard, we had it there. Now, obviously, to get the slope, we have to divide by 2. But all I really care about is right here. So, Brecken, parallel, perpendicular, or neither? Neither one. They're not negative reciprocals, so they're not perpendicular, but they're also not the same, so they're not parallel. They just happen to intersect somewhere. At your seats, I want you to do number 7. Are those parallel or perpendicular or neither? Number 7, page 119. Rendering a verdict. And what is our verdict, class? Yes or no parallel? Yes. Good. Here, move the 2x over. As a negative, divide by 9, negative 2/9. Here, everything was negative, so I changed everything to positive. Again, all I would have had to do is move both of those over and this over, and then flip it back around again. But I'm too lazy for that. Just knock all the negatives off. And then the same thing. Move the 2x over as a negative, divide by 9. Yep, negative 2/9 again. Look at number 9. We would need to find the slopes of these lines. At your seats, look at line 1. Find for me the slope of line 1. Number 9, find for me the slope of line 1. y2 minus y1 over x2 minus x1. Maddie? Negative 1. All right, at your seats, now find the slope of line 2. Noah? Also negative 1. So, class, the verdict is parallel to each other. Turn the page. Turn the page. Look at number 26. Number 26, get those equations for 26 into slope-intercept form, and let's figure out, based on the slopes, what's going to be true of our lines. Parallel, perpendicular, or neither. Number 26, rearrange those equations into slope-intercept form, at least far enough to get the slope. get a positive 4 sevenths for the first one? Did you get a positive 7 fourths for the next one? So what's the verdict on the lines? They're just lines. They're just intersecting each other because they're reciprocals, but they're not class negative reciprocals. So they are not perpendicular. All right, how about number 27? Numero 27 up. Maddie, what's the verdict? They are perpendicular. Now, technically, we'd want to reduce this to a 3 and to a negative 1/3, but the question wasn't what's the slope, so I don't have to even reduce it to see that, yeah, these are negative reciprocals of each other. They are perpendicular lines. Did we get that for number 27? Number 32. Number 32. Let's find the slope of line 1 and line 2. Using the slope formula. No, what did you get for the slope of the first line?
3 over 2.
3/2. How about the slope of the second line, Brecken?
6 over 3.
6 over 3 over 2, in other words, right? So class, what's the verdict? Not perpendicular, not parallel, just intersecting lines. In fact, they're both positive slopes, aren't they? So one goes up at a rate of 2 to 1, and the other at a rate of 3 to 2. So they're very, very similar slopes even, but they're not going to be parallel. They're certainly not perpendicular. Number 31. Number 31. All right, Maddie, line 1, what's the slope? What about line 2? So what's the verdict? 4 parallel, right? -3, +3. They're negatives, but not negative reciprocals. So again, just intersecting lines. Now, at least they go opposite directions now, right? Whereas last time they were both going up, just at different rates. These are at least crossing, going different directions, but they're still not perpendicular. Number 29. Noah, the first line you had?
Negative 5 over 3.
Good. Initially, the negative 10/6, so that reduces to negative 5/3. Good. And then what about line 2?
Positive 3 over 5.
Positive 3/5. So the verdict?
It's perpendicular.
This time they are perpendicular. They are negative reciprocal slopes. Questions on that? All right, now, want to delve into another type of problem. Write this down in your notes if you would. I want you, we're going to begin doing problems like this here in just a moment. So find the equation of the singular line through the point, let's go with a negative 2, 3, that is parallel to y equals 2x negative 7. We're going to begin working problems like this as we round out the hour. So the idea is you're already given one line. Now, if we were to take the time to graph this line, we know that the y-intercept class would be at, if we were to graph this line class, our y-intercept would be at negative 7. Okay, and then from there we would rise 2 and run 1. So we know we get a line that looks something like this, correct? Now I know this, that there are literally an infinite number of lines that would run parallel to this one, correct? I also know that if I gave you a random point, negative 2, 3, that there are an infinite number of lines that could be drawn through this point, correct? But through this point, there is only one line that could be drawn parallel, right? Of all the lines I could draw through the point, only one of them can be parallel. Of all the parallels I could draw to this line, only one of them will go through this point. Agreed? And so the problem here is let's find the equation of the line. Now, if I were graphing it, I mean, just go up 2 over 1, draw the line. I can graph the parallel easily. But I want the equation of the line through that point parallel to this line. Now, here's the key. Whenever you see parallel, you need to think 2 words. Same slope. So, if I want the line to be parallel, class, that means, well, obviously I need the same slope. Well, what is the slope?
2.
So in other words, I want to know the equation of a line with a slope of 2 through the point negative 2, 3. Wait a second, this is what we've been doing the past couple days. This is what was on the quiz. It's just worded differently. Instead of saying, given a slope of 2, given a point of negative 2, 3, find the equation of a line, it says, well, we have an existing line. Find the equation of a... You read between the lines here, pun intended, I guess, and yeah, all you're doing is doing what we did before. So to find the equation, class, we'll still start with y equals mx plus b. And then for y, we'll plug in the only y value I know, 3. Okay, otherwise I'd be having the same line I just had. I don't want the same line, I want a parallel line. Okay, 3. I plug in the m that is going to match the m of this equation, 2. The x of the point I'm going through, plus b. And when we multiply, of course, we get negative 4. We add that to the 3 to get 7. So b is 7, m is 2. What is the equation of this parallel going to be, class? Y equals 2x plus 7. This, of course, being y equals 2x minus 7. Okay. Questions on that? We could do the same thing, or a very similar process, if, for instance, instead of saying it wanted the parallel, it said it wanted the perpendicular. You understand that to this line there are an infinite number of perpendiculars I could draw, right? But only one of the perpendiculars will go through this point. And again, of all the lines I could draw through this point, only one of them can be perpendicular. So the question is, what is the equation of this perpendicular? Well, anytime you see the word perpendicular, class, you need to be thinking 3 words. Slopes. Negative reciprocal slope. Class, what 3 words do you need to think when you see perpendicular? Negative reciprocal slope. So, this equation has a slope of 2. If I want the perpendicular, I want a slope of -1/2. And then we do exactly what we did before. Y equals mx plus b. We plug in for y the 3, in for the x the -2. But in for the m this time, -1/2. Negatives will, the 2's will. So this whole thing just becomes a +1, which I would move over as a -1 to get 2. So apparently, if my y-intercept is 2 and my slope is -1/2, the equation of this perpendicular class is going to be there we go. And so again, finding the equation of a parallel line or finding the equation of a perpendicular line is really just more of the same thing we were doing, as long as you remember that parallel means class same slope, and perpendicular means at your seats. Do number 13 and number 35. Do numbers 13 and 35. Page 120, number 13 and number 35. Number 13 is a parallel. Number 35 is a perpendicular. Maddie, did you get them both? Excellent. Noah, did you get them both? And Brecken. Y equals -1/4 x minus 8. Did not get that one. You got the first one? Okay, but did not get the second. Just like I said, wait a little bit here. All right, so the first thing we had to do was recognize, by the way, this little triple dot, I'll use a lot. Have I explained? It means therefore. Anytime you see that triangle of dots, means therefore. So through -12, -5, perpendicular to y equals 4x positive 15, perpendicular means negative reciprocal slope. So perpendicular, therefore, means m, or slope, has to be -1/4, right, to get that negative reciprocal. See? Am I looking at the right one?
14?
13 and 35?
I think 14.
Well, 14 would have been, so you did 13 and 14. Oh. Well, we're going to do 14 in just a minute. So, do you understand what we should have done on 35 then? Right, negative reciprocal slope, plug it in for m, there's x, there's y, the -12 and -1/4 cancel to give positives, and 12 and 4 cancel to give 3. Positive 3 moves over to negative to get -8. We good to go? All right, 14 and 34 now. And Brecken, you're done with one of those already. So. Do we get number 14 correct? Y equals negative 4x negative 5. And number 34, y equals 5 halves x positive 3. Excellent. Let's do just two more of these then, 16 and 36. 33. 16 and 33. I was like, I don't think there is a 36 actually. Oh, there is. I'm going to do it because lazy. Both of these correct. Did anyone notice that this is a y-intercept, 0, 3? So in other words, once I found the slope, I already knew b. I could have gone straight to y equals negative 3x plus 3. Anyone happen to notice that? That's okay, you don't have to. Just lazy mathematician in me, I'm always looking for shortcuts. I went in and showed the work assuming you probably would do that, but you know, spots, shortcuts like that in the future. Any questions on parallel, perpendicular stuff? Questions there? All right, look back, or look over, excuse me, to page 122 now, page 122. And I want you to do numbers 28 through 33, true or false. If the statement is false, though, change the bold portion to make the statement true. So modify true, false, numbers 28 through 33. Let's see how we did. This is not a quiz, okay, but if it were a quiz, I'm curious to see how we do. Number 28. Lines parallel to the horizontal axis have 0 slope. Maddie? True, because to be parallel to the horizontal axis means the line is also parallel, or a horizontal. Horizontal lines have no slope. That is true. Number 29. Lines perpendicular to the horizontal axis have 0 slope. True or false? Noah?
Unidentified.
I'm sorry?
Unidentified.
Not unidentified. Those are flying objects. Undefined is the word. Make sure you change that there. Undefined is what you're looking for, not unidentified. Number 30. Maybe you read too much sci-fi. I don't know. Number 30. Two perpendicular lines have the same slope. Coming back to Noah.
Parallel.
Good. Parallel. Two parallel lines have the same slope. Number 31. Two lines with different slopes are intersecting lines. Maddie? True. Different slopes always means they intersect. It doesn't necessarily make them perpendicular just because they're different, right? Like 2 and 3 are different, right, Maddie? But that wouldn't make them perpendicular. So yeah, if they're just different, nothing special, just intersecting lines. Number 32, back to Maddie, the negative reciprocal of -4 is 1/4. That is true. Number 33, the graphs for the equations y equals 3/5 x plus 2 and y equals -5/3 x plus 2 form parallel lines. Noah? Perpendicular lines. Good. By the way, they would both intersect at that y-intercept of 2, wouldn't they? Both have the same y-intercept. So at that 2 is where the two perpendicular lines would cross each other. Questions on that? All right. Turn back to page 121 now. Now, I'm lazy, right? So what we're going to do, we're not actually going to graph these first 6 points on numbers 1 through 6. But I want you to picture them in your head and identify in which quadrant would they fall. Does that make sense? We're not actually going to graph them, but picture where you would graph them and mentally determine the quadrant. 1 through 6 on page 121. Now, if you just cannot do it mentally and you want to do a quick sketch, okay, fine, you can quick sketch, but I think you could do them in your head. That's not going to be up on the test though, Bracken. So Gavin can see what Bracken was looking at. Right, okay, so number 1, -4, 3. Mentally now, I'm like, okay, that means backward 4, upward 3, class is in quadrant 2. Number 2, over 2, down 5 would be in quadrant 4. Backward 3, upward 7, class, quadrant 2. Backward 2, downward 3, quadrant 3. Backward 5, upward 2, 2, and over 3, upward 2, quadrant 1. So 2, 4, 2, 3, 2, 1 would have been our answers there. Did anyone get all 6 correct? Okay. Which one did you miss? Or ones did you miss? Number 2, or you missed 2 of them?
I just missed number 2.
Number 2. Okay, so you did not go forward 2, downward 5. Okay, would have been in quadrant 4. Graphing. There are going to be just a few equations for you to graph on the test on Friday in lesson 124. You're going to have the choice of how you want to graph the equation. So, well, this section is telling you what to do. On the test, you're going to have the option of how to graph. Now, you'll notice the next section says plot 3 points for each line. I don't want to plot 3 points for each line. I think that's highly inefficient. But I want you to at least picture number 7 for a moment. X equals 2. Something feels like it's missing, right? But if we were to graph by plotting 3 points, right, we would set up an XY table, wouldn't we? And we plug in for the letter that's not by itself. We notice X is by itself, isn't it? In the equation X equals 2. So we plug values in for Y. What are some values we might plug in for Y, class?
0, 1, 2.
And the only problem is there's not a y to plug in for. You know why? There's no y. Because it doesn't matter what you plug in for y. X is always just going to keep being 2. Now picture this. If x is always 2, it doesn't matter what y is. X is always just 2. What would that look like? An undefined line where x is 2. Doesn't matter what y value you have. All different y values, but x always stays 2. Does that make sense? So, now we've seen that. Number 9. What do you think y equals negative 5 would look like? No table, just what do you think y equals negative 5 would look like? A zero slope line, a horizontal line. Where would it be? Passing through negative 5 on the y-axis. Does that make sense? All of these, again, x is anything. There's all different x, y axes. 0, 1, 2, 3, 4, 5. But y is always negative 5. 0, negative 5, 1, negative 5, 2, negative 5, 3, negative 5, 4, negative 5, 5, you get the idea? Right? So x equals always forms a vertical line. Y equals always forms a horizontal line. Just kind of something interesting there to tuck away. As we look, for instance, at number 8 right between them, x negative 2y equals 6. I think there's one best way to graph it. XY table is never my best way. I hate XY table, unless I really, really have to. There are some times in higher math where we get some crazy looking equations and we have no clue what to do and the XY table is the only option. Okay, but normally I've got 2 good methods. What are my 2 good methods, Noah?
The intercept and the slope-intercept form.
Right, intercept method and slope-intercept form. Which method do you want to try here for graphing? Intercept method. Yeah, I think it's kind of screaming at you, right? Whenever the constant is easily divisible by both coefficients, 1 and 2, the intercept, now if this were a 5, no, I don't feel like, trying to plot that. But yeah, the intercept method I think is really good. What are the 2 intercepts? Find them at your seats. Find the 2 intercepts at your seats. And Maddie, once you have both intercepts, tell us what they are. Good. And so for graphing, of course, we'd go 6, 0, 0, negative 3, and we just connect the dots and we'd have our line really easily. Look at number 16, though. Right? How can we take care of the effect? Brecken? Well, even plugging in zeros, I've still got these nasty, I hate fractions, Brecken. Man, do I hate fractions. No help? Maddie? Oh, praise the Lord. I was like, no, my indoctrination has failed. Multiply everything by the LCD. It's an equation. It's what we do when we see fractions. At your seats. Make it not look so Make it look less And when we make it less, Brecken, back to you, what does it look like? Yeah, see, that's so much less, isn't it? Yeah. Now, that sets us up for the intercept method pretty nicely. At your seats, find the intercepts. At your seats, find the intercepts as it instructs you to do. Now, that's not the only way to do it, but we'll humor them here, huh? And Brecken, when you've got them.
6, 0, 0.
There we go. And of course, 6, 0, we already plotted for the last one. 0, 8 be somewhere, maybe up here-ish. The line looks something like that. Now, what if, though, we're told, or we just decide, I like slope-intercept form. That's just what I'm going to do. You realize slope-intercept form, the key is y by itself, right? And fractions don't faze me, correct? Because I expect the slope to probably be a fraction anyway. All I care about in slope-intercept form is y by itself. Here then, I wouldn't multiply by the LCD. I'd multiply by whatever I need to get y by itself. Does that make sense? So I would class multiply by 2. Multiplying by 6 didn't get me y by itself, but if I were to multiply by 2, notice I would get here, Noah. Oh, careful, that's 2 over 1, so 4/3 x. Y, right? The 2's cancel.
Equals 8.
Yeah. And then I just move the 4/3 over as a, to get y is equal to
4.
Noah, when you move a 4/3 x to the other side, it becomes, oh, class help him, negative 4/3 x. Just change signs, right? Plus 8. Need more sleep at night. You know this stuff. Oh boy. All right, but do you see how if I'm going for intercept form, I want the fractions gone. If I'm going for slope-intercept form, all I really care about is multiply whatever it takes to get y by itself. Do you see that? Rather than multiply by the 6 and then having to divide everything by 3 again. That seems like a waste of time, right? So I want to show you that shortcut. I know. All right, well, let's review some terms real quick. I feel like if we're this brain dead, maybe terms is a good thing to review as we look ahead to the test, because there's a lot of terms, aren't there? Terms like, what do we call those number lines, class? Yeah, those two. What do we call them? Axes, yeah. Which one's the vertical axis, class? The y-axis. Which one's horizontal? X-axis. The x-axis goes to the left to what? Negative infinity, to the right to positive infinity. The y-axis goes up to and down to. And they intersect each other at a point called the origin. 4 sections formed by the intersecting axes. Quadrants. And we already reviewed which quadrants were which, right? Starting in the shape of let's see, 1, then 2, then 3, then 4. We said that every single point has a particular x value, or what do we call the x value of a point? It's not the ordinate, it's the other one. Abscissa.
Yeah.
Abscissa. The abscissa. All right. And has a particular y value we call the ordinate, in which for the abscissa with the ordinate we have the points coordinates. Good, we put them in parentheses with a little comma between them. Straight lines are formed by what kind of equations? Linear equations. Linear equations graphed as straight lines. How do I tell by looking at an equation, not the graph? Obviously, if it's a straight line, hey, that's linear. How do I tell by just looking at the equation itself? Hey, that's a linear equation. To the first power. This, for instance, is a linear equation. I don't have both x and y. The x is a 0x, technically, but it's to the first power. Here I have a 0y, but it's to the first power. X and y's are to the first power. There's no squares, there's no cubes, there's no weird exponents, right? So no exponents other than first power's linear equation. We said a linear equation typically, not always, will intersect both axes. Now here, it only intersects the x-axis. This one only intersects the y-axis, but most equations, unless they're vertical or horizontal, they're going to intersect both axes, and the points where they intersect the axes are class called intercepts. Good. And to find intercepts, we plug in zeros, right? 0 for the other letter. We said that every line has a particular amount of slant to it, but we don't call it slant, we call it represented by the letter M. And slope is defined as what over what? Rise over run, where rise, of course, is a vertical change, run is a horizontal change. We said that a line that goes straight up has what kind of slope? Undefined slope, because it never runs. A line that goes perfectly horizontal has 0 slope, it never rises. A line that rises and then runs to the left, negative. It's a line that appears to go downward, right? But it has a negative slope. And a line that rises and then runs to the right has positive slope. Lines that have the same slope, of course, are lines that have negative reciprocal slopes are perpendicular. And if they just have whatever slope, then they are just intersecting lines. They're not special, not parallel or perpendicular. Hi, Noah. All right. Of course, you want to remember on graphs, we always need to put what's on the ends of the graphs, on the ends of the axes. Little arrows go into infinity, negative infinity. We also would need to label which one's x, which one's y, to indicate we're doing Cartesian graphing, right? That thing we graph on is called the Cartesian plane, also called the coordinate plane is the other name for it because it's got coordinates all over it. And of course we want to put our increments, right? Number, usually every 3 or so, all right? Test coming up on Friday in lesson 124. Tomorrow we will be reviewing. We'll start by looking at the handout. Some things to note about the test. The test will cover sections 11.8 to 11.10 and chapter 3. So remember we took a test on fractions, and then after the test we talked about complex fractions, rational equations, and word problems with fractions. That's going to be on the test along with all the graphing stuff that we've been doing. All right, so we'll be reviewing tomorrow, test Friday. Make sure you have your handout with you tomorrow. Have a wonderful rest of your day.